Weight Shift Control 11.1 Approaches and Landings. Approaches and landings, being critical maneuvers, require skills developed through basic flight and ground reference maneuvers, as well as an understanding of airport traffic patterns. Typically, landing is one of the final maneuvers a student learns before solo flight, involving considerations such as environmental variables, aircraft speed, descent rate, and distance above the ground. This discussion focuses initially on the fundamentals of a normal approach and landing in calm winds on a large, hard-surfaced runway. This provides a foundation for specific maneuvers like power-on, crosswind, and steep approaches, which are common in weight shift control operations. In a normal approach and landing scenario, considered a simple situation, procedures involve idle engine power, light wind, a direct final approach into the wind, no obstacles on the final approach path, and a firm, sufficiently long landing surface. The selected landing point should be beyond the runway's approach threshold but within the first 1/3 portion of the runway. For normal landings in calm conditions, it's common to bring the throttle to idle at the start of the base leg. However, the throttle may be used above idle in situations such as initial training, shallower descent angles, or high winds and turbulence. The phases of approach and landing include the base leg, final approach, roundout, touchdown, and the after-landing roll. The placement of the base leg is crucial, starting at a point where power can be brought back to idle, and the aircraft can glide to the landing spot at the recommended approach speed. The intended landing point should be beyond the start of the runway. The final approach involves reducing power and approaching at the recommended airspeed, maintaining a ground track perpendicular to the runway centerline extension. In the roundout phase, the transition from descent to level flight above the runway is a smooth, coordinated movement to avoid ballooning or settling. The actual landing occurs during the touchdown phase, aiming for the selected landing point, with adherence to the manufacturer's recommended procedures. After landing, the after-landing roll requires continued attention to aircraft control. Understanding and mastering these phases and maneuvers contribute to safe and successful landings. Manufacturer recommendations, as outlined in the Aircraft Flight Manual and/or Pilot's Operating Handbook, must be followed, and the principles of normal operations are essential before progressing to more complex operations. In the final approach phase, the aircraft should align directly with the runway centerline, approaching with sufficient energy to land at a predetermined point. This point should allow for variations in approach conditions and runway lengths for either a full stop or a go-around if necessary. Correcting for any crosswind, the ground track should stay aligned with the centerline, with longitudinal axis alignment maintained for a normal approach. Speed adjustments may be needed for the desired rate of descent, and slight increases in power may be necessary to maintain the descent angle at the recommended approach airspeed. The descent angle should be controlled throughout the approach, considering the impact of lift, drag, thrust, and weight. In the descent for final approach, maintaining the recommended airspeed is crucial. If the angle of attack is too high without an increase in power, a rapid descent occurs, potentially resulting in a short touchdown. Stretching a glide by applying forward control bar pressure alone should be avoided, as it decreases gliding distance. The proper angle of descent must be maintained at the minimum speed recommended by the manufacturer, adjusting power as necessary. Estimating height and movement is critical during the final approach, roundout, and touchdown. The pilot's vision should remain focused on the runway centerline or distance from either side within their peripheral field of vision. Accuracy in judging distance depends on clear vision, and the focus distance should be proportionate to the aircraft's ground speed. During the roundout, as speed decreases, the focus distance should also decrease. Focusing too close or too far ahead can lead to overcontrol or delayed reactions. To become accustomed to heights and speeds for a specific weight shift control aircraft, low passes over the runway are recommended, starting with normal approaches, followed by high-energy passes at higher speeds, and medium-energy passes at lower speeds. These exercises help pilots determine height and speed over the runway before actual landings, fostering proficiency in various conditions. The roundout, a critical phase in the landing process, involves a gradual transition from the normal approach speed to a landing attitude. This smooth transition rounds out the flight path, aligning it parallel and just a few inches above the runway. Typically initiated when the aircraft is approximately 10 to 15 feet above the ground during a normal descent, the roundout is a continuous process that slows the aircraft until it touches down. In aviation, the terms roundout and flare are often used interchangeably to describe the process of slowing the aircraft during the final approach and landing. However, This handbook emphasizes the term roundout for weight shift control students, as it provides a more accurate description of the weight shift control landing process. As the aircraft reaches a height where the back wheels are 1 to 2 inches above the ground, the roundout continues by gradually pushing the control bar forward, maintaining this height above the runway as the weight shift control aircraft slows down. This action causes the aircraft's nose wheel to gradually rise to the desired landing attitude. The angle of attack is increased to allow the aircraft to continue flying just above the runway as forward speed decreases, eventually resulting in the back wheels settling onto the runway. Throughout the roundout, the airspeed is decreased to the touchdown speed, and the pilot controls lift to ensure a gentle settling onto the landing surface. The roundout is executed at a rate that aligns the proper landing attitude and the recommended touchdown airspeed simultaneously, coordinating with the point where the wheels contact the landing surface. The rate at which the roundout is performed depends on various factors, including the aircraft's height above the ground, the rate of descent, and the airspeed. Visual cues play a crucial role, primarily relying on the angle at which the pilot's central vision intersects the ground or runway. Proper depth perception and visual cues related to changes in runway or terrain perspective, as well as the size of familiar objects near the landing area, are essential for a successful roundout. Maintaining the same viewing angle helps assess the rate of altitude loss, with forward movement indicating an increase in altitude. Common errors during the roundout, such as rounding out too much and too fast, can be avoided by gradually increasing the AOA with a controlled descent and never climbing during the roundout. The touchdown is the gentle settling of the aircraft onto the landing surface, ideally achieved with the engine idling in calm air conditions. The control bar is used to maintain control during the after-landing roll, ensuring a safe exit from the runway. Following a controlled roundout, the landing process continues until the aircraft decelerates to normal taxi speed during the landing roll or comes to a complete stop, clear of the landing area. It is crucial for pilots to maintain vigilance and positive control after getting the aircraft on the ground to avoid accidents. During the landing roll, the pilot should make only slight turns to maintain direction until the weight shift control has slowed to taxiing speed. Abrupt turns at high speed can lead to potential issues such as lifting a rear wheel, rolling the weight shift control over, or forcing the wingtip to the ground. Therefore, the weight shift control must slow to taxiing speed before attempting any sharp turns to exit the runway. Aircraft brakes play a key role in reducing ground speed, similar to the brakes of an automobile. Maximum brake effectiveness is just short of the skid point, and skidding can be stopped by releasing brake pressure. Brakes should be applied firmly and smoothly as necessary, avoiding alternating brake pressure. Weight shift control aircraft may have either nose wheel or rear wheel braking systems. For nose wheel systems, if immediate braking is required, lowering the nose allows the nose wheel to touch the ground, facilitating brake application. Lowering the nose also increases force on the front wheel, enhancing braking effectiveness. However, skidding of the front wheel should be avoided, as it results in the loss of directional control, requiring the pilot to release brake pressure to stop skidding. Rear wheel braking systems, although heavier and more complex, offer better braking force due to the presence of two wheels and increased weight on the rear wheels. Pilots should evaluate braking effectiveness for each type of runway. Ideally, when sufficient runway is available, the aircraft's speed should be allowed to dissipate naturally with minimal use of brakes. During the after-landing roll, the control bar serves a similar purpose on the ground as in the air, influencing the lift and drag components of the wings. It should be used to keep the wings level. If a wing starts to rise, roll control should be applied to lower it.